Hello and welcome to the JNCIS Enterprise Routing and Switching video training series. My name is Chris Frisch. In this video series we will discuss all of the topics outlined in the Juniper exam objectives for the JNCIS ENT exam. This course is designed to give you all of the need-to-know information related to this exam. This video series is very to the point and specifically addresses the Juniper exam objectives, so you do not have to sit through endless hours of training to get the information that you need. It is recommended that you pause the video and take notes when you need to, and do not hesitate to re-watch a section if you feel the need. This series will be mostly video-based, but there will be some lab assignments as you go. We will be starting this series off by discussing the switching portion of these objectives. This is Session 1, Juniper EX Switching and Basic Layer 2 Switching. The first key points we're going to discuss here are shared versus switched LANs and the switching mechanism. A shared LAN has a single collision domain and a single broadcast domain. For example, if there are three users A, B, and C, then the traffic sent by user A to user C will also be sent to user B because user A will flood the traffic to all ports and thereby increasing the chance of a collision. The best example for a network like this is a network that uses a hub where the users share the same collision domain. Shared LANs use CSMA/CD protocol to avoid collision of frames. On an Ethernet LAN, transmission happens by flooding of data. If the line is idle, the node starts transmitting data. A collision will occur when multiple nodes start transmitting data at the same time. In this case, a jam signal is sent by the burst of data to all devices. Stop transmitting immediately and will wait for a particular interval of time and then start retransmitting again. The time will keep increasing if more collision detection occurs. The node uses a contention algorithm to calculate the increasing retransmission time intervals. Switched or transparent bridge networks have multiple collision domains and a single broadcast domain. They are used to maintain a forwarding table and to forward the data accordingly. Just like we saw earlier, where all the users were in the same medium or collision domain, where a collision domain is divided into subdomains or multiple collision domains. The forwarding decision is based on the forwarding table or bridging table. If we send traffic from user A to user C, it will be done by the bridging table. Let's look at this a little closer. These are the mechanisms used by a switched LAN. Let's discuss the mechanisms used on the switched LAN. We have learning, forwarding, flooding, filtering, and aging. First of all, let's talk about learning. The switch will check the Ethernet header and will check for the source MAC address associated with the interface, then update it in its bridging table. Forwarding. It will check the bridging table to find the forwarding/destination MAC address entry with the associated interface. If we have multiple VLANs, then it will forward the traffic to the associated VLAN. Flooding. If the MAC entry is not in the switching table, i.e. for unknown MAC address, then it floods the MAC address to that VLAN within the same broadcast domain. Filtering. The filtering mechanism is used to limit traffic to its switch port or VLAN. As the number of entries in the bridge table grows, the switch pieces together an increasingly complete picture of the individual network segments. The picture clarifies which switch ports are used to forward traffic to a specific node. The switch uses this information to filter traffic. And then we have aging. To keep the MAC table entries updated, the switch monitors the MAC address activity and ages out MAC addresses after a specific period of time. On EX switches, it is 300 seconds. This can be either for source addresses or destination addresses or both. The network on the basis of switches perspective is divided into three parts or layers. The order described here is from user to internet. We have the access switch layer, we have the aggregation switch layer, and then we have the core switch layer. The access switch. These switches are connected to users connecting to laptops, PCs, hubs, dumb devices such as printers, scanners, or mobile devices. These switches act purely as layer 2 switches. An example of these types of switches would be EX4200s, EX3200s, EX2200s, or 3300s. And then we have aggregation switches. These switches are used for providing the access layer's connectivity. Inter-VLAN routing and policy-based routing. It is a mixed bag of layer 2 and layer 3. Then we have the core switching layer. This is where all the routing is happening. Aggregation switches pass all prefixes and activities to these switches. These switches act as gateways towards ISPs or the Internet. Often in larger enterprise networks, it is useful in connecting to gateways such as firewalls or routers. Just remember, you can implement class of service at any of these layers. Now let's talk a little bit about Juniper's consolidation of these 3 layers in an architectural solution. As networks and industries grow, so does their device inventory. Years ago, engineers found a solution to the processing of network traffic and data. That solution was the data center. Now issues arise in terms of cost-effectiveness and redundancy in the network as layer 2 switches often fall short as far as versatility. To overcome this, Juniper came up with the 3-2-1 architectural solution to trim the tree from layer 3 to layer 2 and finally to layer 1. And this architecture does not correspond directly to TCP/IP or the OSI layers. For small IT data centers, layer 1 can be cut out and limited to layer 2 by putting the switches into virtual chassis. For larger data centers, Juniper came up with an entirely different architectural and hardware solution known as Quantum Fabric or QFabric. Running a single instance of the Junos OS, QFabric brings drastic changes to the data center. QFabric is a very interesting solution, but it's a bit outside of the scope of this course as far as configuration and technical information. Now let's talk a little bit about the benefit of the 3-2-1 architecture. Virtual chassis technology allows multiple interconnected switches to operate as a single logical device. This means that management of switch stacks can be done from a single point. Virtual chassis will be discussed in detail in the next chapter, though. Now let's talk a little bit about control and forwarding plane functions. On the basis of software or hardware design, Junos-based devices are divided into 2 logical parts: the control plane and the forwarding plane. So let's talk a little bit about the control plane. The routing engine resides in the control plane and is the brain of the device, and it is responsible for performing protocol updates and system management. It maintains the routing table, MAC table, primary forwarding table, and connected to PFE through an internal link known as SFID. Any control message or new route or MAC learned from the forwarding plane will be sent to the control plane to update the database and then update the forwarding table for quick lookup. Forwarding plane, or the packet forwarding engine, is responsible for the forwarding of transit frames, packets, or both through the switch. These can be the frames updated in the forwarding table for quick lookup and doesn't require any processing. The PFE is an ASIC chip. The PFEs on EX switches varies from platform to platform, as this is a hardware specification. The interfaces are mapped to PFEs only. If the control plane fails, then there is no interruption to transit traffic. It will allow any traffic not destined to the switch. Let's talk a little bit about frame processing of unknown source MAC addresses. If a frame enters the ingress of an interface, then the information will be relayed to the PFE associated to that ingress. If the PFE performs the MAC address lookup and finds that the MAC address is unknown, it will send the header information to the RE. Now, the routing engine will either add or discard the frame, depending upon the firewall filter or MAC limiting. If it adds the frame into the bridging table, it will then get programmed to all PFEs. Now let's talk a little bit about transit traffic from known and unknown destinations. Say a frame enters an ingress port and associated PFE. A MAC lookup is done, and if a match is found, it will pass the frame to the egress PFE and forward it to the egress port to pass it to the destination. If the destination MAC address is unknown or not listed in the MAC table, then it will flood the frame to other PFEs and local ports within the same VLAN. Other PFEs flood the frame to egress ports within the same broadcast domain, or VLAN. Okay, let's take a look at a few commands to check interfaces, VLANs, processes, and bridging table information in a Juniper EX switch. First of all, let's look at the Show VLANs command. As you can see, this will show you the VLANs that are configured on the device and which ports are associated with that VLAN. Alright, now let's take a look at checking the MAC addresses on the bridging table. We can issue the command show Ethernet-switching table extensive. And as you can see, this will show us the information contained in the Ethernet switching table, including VLANs and interfaces. By creating VLANs, you can separate different parts of your organization and network. This will make management of interfaces and connecting peripherals easier, as well as increasing the security of your network. There are two different kinds of Layer 2 ports, access ports and trunk ports. Access ports receive untagged frames that can be associated with one or more VLANs. EX switches come with a default configuration of access ports on all of the main ports. Trunk ports will add an extra field on the Ethernet frame between the source MAC address and the Ether type field. In this snippet, the tag field will carry the information of the VLAN. You can associate multiple VLANs to the trunk port, or all of the VLANs to the trunk port. On the trunk port, you can also configure native VLAN ID for untagged frames. An example of a reason why you might want to configure this is when you have a PC that's plugged into the switch port on the back of a phone. Now, the PC might not be using a VLAN, but the IP phone is, so the IP phone is sending tagged frames. In this scenario, you can have the interface say GE000 as a trunk, and you can configure the voice VLAN for that interface. Now, data traffic, which is from the PC, will send untagged frames. You can create a native VLAN configuration and map the data VLAN under it. Here's an example of how you might configure this. First, we'll configure the data VLAN here, and then you'll configure the voice VLAN. We have the data VLAN 10 and the voice VLAN 20. Then we'll configure an interface as a trunk port, and then we'll assign VLAN member's voice to that interface, and then we'll also assign the native VLAN ID 10 to that same interface. Now, in the last configuration command, notice that we used the native VLAN ID command, and we set that to 10, which was the same VLAN ID as the data VLAN. So basically, we're dumping all of the untagged traffic into native VLAN 10. On Juniper EX switches, all of the interfaces by default fall under the default VLAN. All installed interfaces are pre-configured for Layer 2 operations as access ports and are associated with the default VLAN. You can simply plug in an EX switch into a basic single domain environment without any configuration. If multiple broadcast domains are required within a single switch, you must define an additional VLAN for those. What is a routed VLAN interface, or RVI? An RVI is a logical Layer 3 VLAN interface used to route traffic between VLANs. This Layer 3 interface is associated with an IP address and will be the default gateway for the users associated with it. On Juniper EX switches, inter-VLAN routing within a switch is possible through these RVIs. A key point to note here is that RVIs are typically implemented in either the aggregation layer or the access layer, depending on the network design and implementation. All EX series switches support RVIs as well as other Layer 3 routing operations. Let's take a quick look at how to configure an RVI. First, we create a Layer 2 VLAN. Next, we create a logical Layer 3 VLAN interface. Then, we link the Layer 2 VLAN to the Layer 3 VLAN interface. Then, we verify the logical VLAN interface is up using the following command. At least one port, access, or trunk with the VLAN assigned to it must be up for the Layer 3 VLAN interface to be up. To verify the routes via the logical VLAN interface, use this command. Alright, so let's review. What are the key differences between shared and switched LANs? Switched LANs break a single environment into multiple smaller collision domains, which minimize the chance of collisions. Shared LANs place all devices into a single collision domain, which increases the chance of collisions, especially if a large number of devices are connected. Switched LANs make intelligent forwarding decisions based on the contents of the bridging table, while shared LANs always flood traffic, which consumes resources unnecessarily and can pose some security risks. Alright, so let's list and describe the bridging mechanism. Learning is a process that the switch uses to obtain the MAC address of a node on the network. The forwarding mechanism is used by the switch to deliver traffic, pass it from the incoming interface to an outgoing interface that leads to the destination. Flooding is a transparent mechanism used to deliver packets to unknown MAC addresses. The filtering mechanism is used to limit traffic to its associated broadcast domain or VLAN. Finally, the switch uses aging to ensure that only active MAC address entries are in the bridging table. What layers exist in the hierarchical Layer 2 networks, and what functions are associated with each layer? Layer 2 networks can have access, aggregation, and core layers depending on the size and implementation approach. The access layer facilitates end-user and device access to the network and enforces access policy. The aggregation layer connects access switches together and often provides inter-VLAN routing and policy-based connectivity. The core layer switches packets between aggregation switches and functions as the gateway to the WAN edge devices. What Layer 2 port modes can be assigned to a port? What Layer 2 switch modes can be assigned to a switch port? Let's describe the operations of each. Switch ports can either be in access or trunk mode. By default, Layer 2 interfaces on EX switches are in access mode, which means they connect to end-user devices and pass untagged traffic. You can configure Layer 2 interfaces for trunk mode, which means the interface passes tagged traffic. Switch ports in trunk mode typically connect to other switches or edge routers. What is the purpose of a voice VLAN? Typically, access ports only relay untagged traffic and are associated with a single VLAN. In some implementations, you may have an IP phone with a PC both connected in a single switch port, in a daisy chain fashion. The voice VLAN feature allows you to associate the data and the voice VLAN with the same switch port and permits both untagged data VLAN and tagged voice VLAN traffic to pass through the access port. When is the native VLAN ID option used? The native VLAN ID option allows you to associate a specific VLAN with untagged traffic on a specific trunk port. This option is most often used with the default VLAN because the default VLAN's default VLAN ID of 0 is not allowed to appear in the tag field of a tagged packet. Describe how inter-VLAN routing can be implemented on a switch. You can use RVIs to implement inter-VLAN routing on an EX switch. An RVI is a logical Layer 3 interface and is associated with a specific VLAN. The IP address assigned to an RVI functions as the gateway address or the end-user devices within a given VLAN. That's it for Section 1. Now it's time to test your knowledge with a short quiz. Remember that if you feel the need to watch the video again, we recommend that you do so. Thanks for watching.